Assalamualaikum warahmatullahi wabarakatuh. To Dr. Marian Jamilah, Dr. Fahana. My name is Muhammad Naib Abu Bakar. Today I want to present my project, crop disease detect and control on the vertical farming using image processing. So the introduction is about vertical farming. It's indoor farming using vertical structure. Its function to produce food as demand increase, and probability can reduce food crisis in the future. So how it works using hydroponic planting technique, CAA, controller environment agriculture, use temperature sensor, LED and humidity sensor. Still use human labor for planting, monitor, control and harvest group. So the problem statement is vertical farming had to do inspect daily for the sign of disease. Due to vertical structure, worker had to use scissor lift to access upper row. So this is a risky activity. Other than that, human has a limitation on inspection and collect data. So the solution is to build a system that can access every row and can detect and control the disease. So the first objective of the project is design a detect and control system for the crop disease using Arduino Uno and PC2 camera. Second is develop image processing system for information extraction of crop disease using Matlab software. And lastly, to analyze the accuracy of the system detection by using support vector machine technique. So this is three objective of the project. So we go to the literature review. First is about the disease. These two diseases will be detected in this project. First is powdery mildew disease. It's a common disease that affect by the fungal. The disease easily to identify as we can see by naked eyes. It has a white powdery and grey white spot on the leaf. And then the downy mildew disease, also most widespread disease on the lettuce. Disease causes by the Bremia lettuce plant pathogen and commonly developed in low temperature growing disease. These two diseases will be detected will be a subject in this project. So method, we have to this disease capture by PC2 CMU camera, and then the image we upload to the Arduino, and Arduino will save it in a specific folder in computer. The computer has Matlab software that has image processing toolbar. So the image will be processed to identify the type of the disease. We have to use database to result classification and for the accuracy. And then Matlab will send the input to the Arduino for controlling process. So controlling process will be done by the spray pump. This is a prototype design. We have LED panel and we have camera at the top of the plant. We have hydroponic drain and liquid fertilizer bulb. So this is a circuit diagram. We have Arduino Uno that microcontroller that control the camera as control the input from camera. We have stepper motor. Stepper motor will moving the camera horizontal through the vertical farming. And then we have spray pump that attached with relay. So Arduino also will control the relay. So this is the flowchart. This flowchart only focus on the image processing because in the FYP1 I focus in both system of image processing that detect the disease. So we start with the image capture by the camera. It will feed to the image acquisition. Image acquisition will import the image to the Matlab software, and then image pre-processing will be remove any distortion of the image. Image segmentation will be divide image into a few clusters. Feature extraction will be extract useful information from the cluster. Image classification will be use feature extraction information to classify the type of the disease, and we have the disease name as a result. So the classification also connect to the database uh, for future analysis. So image acquisition is required latest image as input. So using PC camera, but for FFP1, I only use image from other sources. So I store the image into the specific folder that easily can be get by the Matlab. This is the 10 sample of Downy-Meadow disease that we will feed to the system for getting the preliminary result. And this is 10 image of powdery mildew disease that also will be fed to the system. So image pre-processing function to enhance some image feature for future processing analysis. It also uh, have to also function to remove unwanted distortion on the lip, such as dust, noise, spore, or other thing to produce more clearer image. So in this image pre-processing, we use enhance method. So enhance method, we adjust the color map and image intensity value. So the output image will be more clear, and the disease spot will be more focused. Next step is image segmentation. So the technique is conversion of the JPEG image into several segments and rendering the image into image that can be easy analysis. So for the project, I choose k-mean segmentation cluster method. So what k-mean does is k-mean clustering. We cluster the image of the disease into 3 clusters. So this is the result of k-mean clustering. As we can see from the original image, we will convert into 3 clusters. So for this image, the cluster 1 is showing the infected region. For the original image for number 2, the cluster 2 show the infected region. For the original image number 3, the cluster 2 show the infected region. We have a feature extraction in this section. We want to extract the useful information from the cluster that we choose. So from the image, we want to extract the contrast, the coloration, the energy, and homogeneity. This statistic is from gray level co-occurrence metric technique. Other feature is mean, variance, and standard deviation. So after the feature extraction, we have image classification and database training. So at this step, we use support vector machine technique. This technique will classify the disease name and for the database training. Okay, I'm going to show you the step from image acquisition to the feature extraction by the Matlab. So this is the Matlab coding for the image processing. After we select the image will be divided into 3 clusters. So the disease spot is cluster number 1. At the command window, we will show the feature extraction, contrast, coloration, energy, homogeneity, mean, standard deviation, and variance. So this is preliminary result for the grade level co-occurrence metric GLCM feature. This table is for the Downy mildew disease. For the contrast, number one is a bit higher. From number two, it shows that the area of infection for number one is larger than number two. For coloration, the both value only differ 0.1, so prove the gray tone for the both is same linear. For energy, we can see image number one is 0.5, lower than image number two, which is 0.6. We can conclude here, maybe the image number two disease age or duration is older than uh, image number one. And for the homogeneity, is the value inverse from the contrast value. If the contrast value is higher, the homogeneity will be lower. This is result for the mean, variance, standard deviation for the both disease. So for the mean, we can see Downy mildew disease, we got 32, and powdery mildew disease number 8 is 77. So the mean is present the brightness of the image. We can conclude here the Downy mildew disease segmentation, image segmentation, clustering, give the darker image, only show the darker image. So the mean will be lower. And for the powdery mildew disease, for number 8, it show only the white image. The mean will be higher because it's brighter than Downy mildew disease. And then the standard deviation does reveal something about the image contrast. So as the conclusion, at the end of PSN1, I managed to achieve one of the objectives, which is implement of image processing technique for the disease detection. And I could not finish the last step, which is classifying and data turning. This step will be proceed for PSM2. This project, image processing is from the Matlab software. Technique for using for the segment is k-mean clustering. And for the feature extraction, we use gray level co-occurrence metric to extract information. Extract information will be used input to support vector machine in result classifying and database. Okay, for the future work, we will complete the disease classify and database, and then we'll be proceed to the hardware development, prototype and the circuit, and then implement the system, and will be data collection from the system, and lastly will be report writing. I think that's all for me.